we have this example now. Now in this example we have a few things, all right? Uh, the first thing that I've shown you in this example, the crest curve with respect to stopping sight distance, is that you have a road that has a 5% grade increase and then a 2% grade decline. All right, of course the road is starting at PVC, and I should say it's doing something like that, where it's ending at PVT, the curve of the road. Now, some things that I've given you that you're going to need and you should recognize. The fact that I say here that the design speed is 60 miles per hour, you should already be putting in your mind that, okay, I need to be designing with respect to speed, therefore with respect to stopping sight distance. So I know that the equations that I'm going to use are going to be a little bit different than the ones that I may be used to. All right, so I'm going to write that equation up here. You may be even be able to see it up here from the last sheet that I gave you, but let me go ahead and write that equation now. All right, so if stopping sight distance is greater than L, then I'm going to use this equation. L min is equal to 2s minus 2158 divided by my algebraic difference. Or I could use if the stopping sight distance is less than L, go ahead and put L min, then I can use the equation that says L min is equal to the algebraic difference multiplied by the stopping sight distance squared divided by 2158. Now I'm writing in S here. All right. Now this S is still stopping sight distance. I don't want you to get that confused, but I'm keeping it as S because that is the way that's written on your notes and other reference books. All right. So S means stopping sight distance here. So we're going to use one of those two. Well, since we have stopping sight distance, I guess one of the very first things we have to figure out is what the stopping sight distance should be. Well, there's a couple of different ones that we can use here. I'm going to go ahead and figure out what the stopping sight distance is. So, stopping sight distance is going to be equal to 1.47 times 60, that was given, times 2.5 plus your 60 squared divided by 30, 0.348, and let's just go ahead and, just for the sake of practice here and learning, do a plus 0.02 just to see what we end up with. We should end up with 546.6 feet, which of course you know we're going to use 550 in that case. Okay, let's just go ahead and use this stopping sight distance and see where we end up as far as the minimum length is concerned. All right, so we're going to use this one here. Well, placing this stopping sight distance in this equation, I want to see what I end up getting. Let's start off with if SSD is, we'll start off with less than L. Okay, so we're starting off with this one down here. All right, that means that my L min is going to be equal to the algebraic difference of the grades. Wait a second, let's figure that out first because sometimes that can get us a little bit mixed up. So A is going to be equal to G2 minus G1, which in this case is equal to -2 minus 5. Okay? Now, I don't know if you noticed this on the last slide here, but when we're doing the stopping sight distances for crest curves or sag curves with respect to, sorry, when we're figuring out the minimum length with respect to stopping sight distance, and we're on a crest or sag curve, this algebraic difference needs to be a positive number. So we're going to take the absolute value of those two numbers there, or at least the quantity of those two, and we're going to end up with 7. All right, so our algebraic difference when applying this formula is going to be the absolute value of G2 minus G1. In this case, it's going to be 7. So back to you applying to this equation, we have L min is going to be equal to 7 times 550, and we're going to square that term, and we're going to divide that by 2158, which will give us an answer of 981.23 feet. Okay, well, we tried that one. Let's go ahead and try the other one. If your stopping sight distance is greater than L, then I'm going to use this equation. Lm is equal to 2 multiplied by 550 minus 2158 divided by 7. Or, if you just want to work through everything, -2 minus 5, the absolute value of those two things. And this should give me 791.71 feet. All right, now we just have to figure out which one of these conditions is correct. Now sometimes, let's just say you might figure the first one that you choose is correct, and that means you don't have to continue on. But just for the sake of example and illustrative purposes here, I just continued on and wrote both of them. So let's write this L min. This L right here, this is 981.23. And this one right here is 791.71. Of course, our stopping sight distances are 550 and 550. All right, we'll go ahead and place our signs here. Now we just have to pick out which one of these is correct. Well, 550 is less than 981 feet. Therefore, this one is correct and this one is not. So, we would go ahead and choose a length of 981.23 feet. However, some of you might have noticed and might have even questioned whether or not my stopping sight distance is correct. And if you were one of those people, then good job, because this stopping sight distance wasn't the correct one to use. As a matter of fact, we probably don't even want to use the stopping sight distance of an upgrade. Why? Because, well, if vehicles are traveling both this direction and this direction, the most modest stopping sight distance we can use is one that's going to be on the decline. And in this case, the most modest stopping sight distance we can use is a -5%. So I want to keep this here, and just to see when we use a stopping sight distance of a -0.05 and figure out all of our L mins, I want to compare and see what the L min actually ends up being and how far off we are. So let's go ahead and do that. Again, keeping the same equation, same example, all we're going to be doing is we're going to be using a different stopping sight distance. And let me just draw here what the two grades were again. Okay. Again, we had 60 miles per hour on this roadway. we have to figure out what our L should be. At least our minimum length should be. Okay, let's go ahead and do it again. Determining our stopping sight distance would yield the following. 1.47 again times 60 times 2.5 plus 60 squared, all divided by 30, 0.348 minus 0.05. Okay, that gives me a stopping sight distance equal to 623.1, in which case we would use 625 feet. That's the stopping sight distance we're going to use, not 550 like we used before. Okay, so if S as D is less than L, then my L min equation is going to be equal to 7 times 625 now, squaring that, divide by 2158, and I end up getting an answer of 1267 feet. If my stopping sight distance is greater than L, then I'm going to use the other equation, which is 2 times my 625 minus 2158 divided by 7 here, and that is going to give me a length of 941.71 feet. Again, taking my L mins and placing them right underneath here, just for comparison purposes, I can determine which one satisfies the condition and which one I should actually be using. Stopping sight distance in this case was 625. 625 less than, greater than. By observation, I can see that again 625 is less than the 1267. Therefore, whatever number I got for this equation is the correct number. So, when I do actually use a length, I need to know that if I'm designing for a 60-mile-per-hour road with a grade such as this, I am going to make sure that my L min, or my length, is no smaller than or lesser than 1267 feet. Because in doing so, I will be providing a stopping sight distance that is sufficient for any object on the road in a sight line, or sorry, an eye height of 3.5 feet above from the surface of the road. So now we have our length here. And if you remember in previous classes, I've always given you L, which was equal to, in this case, 1267. I've always given you an L, and I told you that PVI is basically centered at the length of the curve, which of course, remember, is a straight horizontal line. It's not the actual curve length as it was in the horizontal fashion. So this meaning that 1267 over 2 is from here to here, and 1267 over 2 is from PVI to PVT. You can probably imagine that now I can use this length in combination with other equations that we've already talked about to determine what elevations are at any location along the curve. This is the minimum length with respect to stopping sight distance. There are minimum lengths with respect to appearance. There are minimum lengths with respect to comforts, and so on and so forth. Of course, when we're designing, we want to make sure we're designing things for safety first. Therefore, the minimum length for stopping sight distance is the one that is most widely used. And with that, we'll stop this example.